Alright guys, so in this section we're going to be talking about our third and final way of graphing quadratics. We're going to be talking about how you can solve by the quadratic formula, and as well as how to graph from standard form. Remember, so far we've seen both factored form and vertex form. Factored form works out really nice, especially you can factor, pretty easy to solve that way. Obviously we saw in 4.2 that completing the square is a little bit more difficult and sometimes becomes very difficult depending on your coefficients. And so this is kind of a last resort. The quadratic formula is not something that's necessarily something you want to do all the time. You definitely want to first check to see, can I factor? Then would it be possible to complete the square? And if the answer to both of those is no, then quadratic formula is kind of like your last resort. The nice part about quadratic formula, though, is that it always works. And so you're guaranteed that you're always going to get solutions this way. You don't have to worry about something not being factorable or anything like that. The one downside is you've got to remember the formula for it. So let's talk about that formula. So quadratic formula, x is equal to the opposite of b plus and minus the square root of b squared minus 4ac all over 2a. Now it's important, over on the right hand side it says your equation must equal 0, so make sure that when you are using quadratic formula that you've solved for 0 on one side of the equation. Now that's something we normally do anyways, but just a reminder that you always do that. Okay, so let's solve each of the following quadratic equations by using the quadratic formula, simplifying your answers as much as possible. Let's take a look at number 1. So number 1, let's first identify our coefficients. So we've got a is 2, b is -4, c is -8. Okay, so plugging those into our quadratic formula, we're going to take the opposite of b, opposite of -4 is +4, plus and minus the square root of b squared, so -4 squared, minus 4a, which is 2, multiplied by c, which is -8, all over 2a, so 2 multiplied by 2. And this is all equal to x. These are our x-intercepts. Okay, so let's do a little bit of simplifying now. So we know that x is going to be equal to 4 plus and minus underneath our square root. -4 squared is 16. If we take -4 multiplied by 2 is -8, multiplied by -8 is a plus 64. All over 2 multiplied by 2, which is 4. Alright, so as we continue to simplify this, we now have 4 plus and minus the square root of 16 plus 64 is 80, all over 4. Okay, so now let's go ahead and simplify this square root of 80. I'll do that over here. Square root of 80 can be rewritten as the square root of 16 and the square root of 5, where the square root of 16 is 4 and the square root of 5 we'll have to leave. So now what we'll do is we'll continue to solve our answer. So we're going to have 4 plus and minus. We now have the square root of 80 as 4 square root of 5 all over 4. Alright, so one last step to go with simplifying. We're going to look at basically 3 numbers. We're going to use our denominator. Then we also have to check both of these terms in our numerator. What we're looking for is, are they all divisible by a number? And in this case, they are all divisible by 4. We're going to take 4 divided by 4, which is 1, plus and minus 4 divided by 4, which is 1, so the square root of 5, and 4 divided by 4, which is 1. So it turns out that 1 plus and minus the square root of 5 is how we would leave our final answer. Now, obviously, when we get ready to graph later on, what we're going to want to do is type that into a calculator to get some decimal approximations, and that way we'll be able to tell a little bit more easily where those go on the graph. But for our answers, leaving those as exact answers, 1 plus and minus the square root of 5 is as good as we need to get it. Okay, let's take a look at a few more examples here. So on number 2, we've got 2x squared minus 8x plus 20 equals x squared plus 4. So first thing we need to do is get one side of our equation to equal 0. So let's go ahead and subtract x squared from both sides, and let's go ahead and subtract 4 from both sides. That way we'll get our right side of our equation to equal 0. So on the left side, 2x squared minus x squared is just 1x squared. The minus 8x has nothing to combine with. 20 minus 4 is 16, is equal to x squared minus x squared is 0. 4 minus 4 is 0. So the right side of our equation is now 0. All right, so let's go ahead and figure out what a, b, and c are. Our number in front of x squared, our coefficient is a, which is 1, b is -8, c is 16. So we're going to take x is equal to the opposite of b. Opposite of -8 is +8, plus and minus the square root of b squared, which is -8 squared, minus 4 multiplied by a is 1, multiplied by c is 16, all over 2a, so 2 multiplied by 1. Okay, so let's simplify a little bit. We've got 8 plus and minus the square root of -8 squared is 64. 4 multiplied by 1 multiplied by 16 is also going to be 64. So we'll have 64 minus 64 all over 2 multiplied by 1, which is 2. All right, so let's go ahead and keep simplifying. We're going to have 8 plus and minus the square root of 64 minus 64 is 0 all over 2, which the square root of 0 is just 0, and 8 plus and minus 0 is really just 8. So we've got 8 over 2, and so it looks like we actually are just going to have one solution in this case, which is going to be that x is equal to 4. All right, moving on to number 3. So we've got x squared plus 4x plus 6 is equal to 0. Nice part about this one is that it's already equal to 0, and we can say that a is 1, b is 4, and c is 6. All right, so putting those into our quadratic formula, x is equal to the opposite of b. Opposite of +4 is -4, plus and minus the square root of b squared is 4 squared, minus 4 multiplied by a is 1, multiplied by c is 6. All over 2a, so 2 multiplied by 1. All right, let's do a little bit of simplifying. So inside of our square root, 4 squared is 16. 4 multiplied by 1 multiplied by 6 is 24. All over 2 multiplied by 1, which is just 2. All right, so then our square root, 16 minus 24 is -8 all over 2. And now let's go ahead and simplify that square root of -8. So square root of -8, I can rewrite as square root of -4 and the square root of 2. Square root of -4 is 2i. Remember, the square root of a negative, you have to use I to simplify that. And then the square root of 2 you'll leave alone. So now our expression, our answer, -4 plus and minus 2i square root of 2 all over 2. Once again, we'll check to see if we can simplify. So we're looking at -4, 2, and 2. All of those are in fact divisible by 2. -4 divided by 2 is -2. Plus and minus 2 divided by 2 is 1. So I squared of 2, or 1i squared of 2, and then there would be your final answer. All right. Last one to look at. We're going to take a look at number 4 here. So we've got 3x squared minus 6x plus 6 is equal to 0. Rather than going ahead and writing a as 3, b as -6, and c as 6, just to make this one a little bit easier, I'm going to divide everything on both sides by 3. That'll just give us some smaller coefficients, and it will save us from having to simplify at the end. So that's going to change our equation to be x squared minus 2x plus 2 is equal to 0. All right, so now let's go ahead and identify a is 1, b is -2, c is +2. So x is equal to the opposite of b. Opposite of -2 is +2, plus and minus the square root of b squared, which is -2 squared, minus 4 multiplied by a is 1, multiplied by c is 2. All over 2a, so 2 multiplied by 1. All right, so now we've got 2 plus and minus the square root of -2 squared is 4, minus 4 multiplied by 1 multiplied by 2 is 8, all over 2 multiplied by 1, which is 2. So now we can simplify that a little bit more. 2 plus and minus the square root of. In our square root, we should have negative 4 all over 2. Square root of negative 4 is 2i all over 2. And then one last time, we'll check these three numbers. They are all in fact divisible by 2. 2 divided by 2 is 1. Plus and minus 2 divided by 2 is 1. So 1i. So 1 plus and minus I are going to be our two answers for number 4. All right. So now, thinking about kind of those different types of solutions, notice that on numbers 3 and 4, we ended up with complex solutions because there was I as part of our answer. On number 2, we had just one solution. On number 1, we had our two solutions, and they were real numbers. There was not any complex numbers as part of our answer. You can actually tell how many answers and what type they are by one particular part of the formula. And that's the number underneath the square root sign. Notice that on number 1, when we simplified everything, we got the square root of 80, where 80 was a positive number inside of our radical. And that's what gave us two real solutions. Notice that on number 2, when we simplified our radical, we had the square root of 0. And when we had the square root of 0, that gave us just a single real solution. Notice that on both numbers 3 and on number 4, we had a negative number underneath our radical, and that gave us a complex solution in both of those cases. So that number that's underneath the radical, we give a special name. We call it the discriminant. So the discriminant determines the number and type of solutions for a quadratic equation. So we let d equal b squared minus 4ac. In other words, the discriminant is equal to the number under the radical sign in the formula. So the first case, if b squared minus 4ac is greater than 0, like it was on number 1, remember that there are two real solutions to that equation. If our discriminant is equal to 0, like it was on number 2, notice that there is one real solution, and we're going to say that it has a multiplicity of 2. We'll talk a little bit more about multiplicity later in this unit, and definitely in Unit 5, we will be talking quite a bit more about multiplicity and what it means, but want to mention that now so that you can kind of understand what's going on there. Finally, if b squared minus 4ac is less than 0, so our discriminant, our number underneath the radical, is negative, then there are going to be 0 real solutions, but 2 complex solutions instead. So let's do a little bit of practice with our discriminant. So on numbers 5, 6, and 7, we're going to find the discriminant and then determine the number and type of solutions. Okay, so on number 5, let's go ahead and identify a, b, and c. So a is 2, b is negative 4, and c is negative 6. So our discriminant, remember, formula for that is b squared minus 4ac. Again, that's just what goes underneath the radical when you are in quadratic formula. Okay, so plugging those numbers in, b squared is negative 4 squared minus 4 multiplied by a is 2, multiplied by b is negative 6. So then simplifying that, negative 4 squared is 16. And then negative 4 multiplied by 2 is negative 8. Multiplied by negative 6 is going to be positive 48. And then 16 plus 48 is 64. Pretty clearly, 64 is greater than 0. So you're going to have two real solutions on number 5. All right. For number 6, just like with quadratic formula, it's important to make sure that one side of your equation is equal to 0. So we're going to subtract 4x from both sides. So 3x squared minus 4x plus 16 equals 0 is going to be the equation that we'll use to solve for our discriminant. So in this case, a is 3, b is negative 4, c is positive 16. So our discriminant is equal to b squared, which is negative 4 squared, minus 4 multiplied by a, which is 3, multiplied by c, which is 16. So simplifying that now, negative 4 squared is 16. Negative 4 multiplied by 3 is negative 12. Multiplied by 16 is a negative 192. And then 16 minus 192 is negative 176. Pretty clearly, negative 176 is less than 0. So that's what tells us that we're going to have two complex solutions. All right, let's do one more example of finding our discriminant, and then we will talk about graphing. So number 7, we've got 4x squared minus 12x plus 9 is equal to 0. So we've got a is 4, b is negative 12, and c is positive 9. So our discriminant, again, b squared minus 4ac. We're going to take negative 12 squared minus 4 multiplied by a is 4, multiplied by c is 9. Okay, so negative 12 squared is 144. Negative 4 multiplied by 4 is 16. And 16 multiplied by 9 is a negative 144. And then 144 minus 144 is 0, which obviously is equal to 0. And so in this case, we're going to have one real solution with a multiplicity of 2. All right, so that is it for solving, guys. So you can see how the discriminant gives you a nice way to check to make sure you've got the correct number and type of solutions. And obviously quadratic formula, while it does take some work, it's kind of nice because you don't have to worry about factoring or completing the square. It's just kind of a guaranteed way of always solving and getting the answers. That being said, I'm going to go ahead and create a separate video for graphing, so make sure you watch that as well, and I will talk to you again next time.